Okay, welcome back. So we're going to be talking about Lesson 8, Domain and Range. So, state the domain. We're going to be learning how to state the domain and range of discrete relations from a set of points, a mapping diagram, a graph, and using set notation. We'll discuss all of that in just a minute. We're going to state the domain and range of a continuous relation from a graph using interval notation. Okay, definitions. So these are going to be important. So domain is all the input or x values that are valid for a given relation. It is all the possible values for x that make the relation make sense. The range is all the output or y values that are valid for a given relation. So it's all the possible values for y. Okay, so let's talk about discrete relations. Discrete relations, remember, the graph might look like just points on the graph, not joined with a line or anything like that. So, oops, what's that? So, for discrete relations, list the x coordinates for the domain and the y coordinates for the range. Use curly brackets to indicate that this is a set of values. Get used to it, you're going to be doing it a lot. The values should be listed from smallest to largest. If values appear more than once in a set, they should only be listed once. Excuse me, I needed to yawn. Okay, list the domain and range of the discrete relations below. We're going to use set notation. Okay, so let me get a pen. Okay, so list the domain and the range of the discrete relations below. Use set notation. All right, so our relation, the very first one right here, example 1, we've got coordinates 1 and 3, 2 and 4, 5 and 6. Now, notice for the domain, it is all the possible values for x. So all the possible values for x are in this relation 1, 2, and 5, and that's what they have listed there. For our range, it is all possible values for y, 3, 4, 6. And that's what they have listed there. So notice that they use the curly brackets. Okay, so let's do this one over here. So we've got an arrow diagram. So we've got the domain 2 maps to the range 4, and it also maps to 5. Then we've got 4 maps to 3, and 5 maps to 4. So let's list our domain. So our domain, D, is going to be 2, 4, and 5. And then our range is 3, 4, and 5. Okay? So now let's take a look at the graph. So I've got some sort of relation here, okay? And I've got the following points. Definitely list them. So we've got -3 and -4. I have the point up here, -2 and 5. And then I've got a point here at 1 and 3. And then I have another point at 1 and -2. So my domain, D, equals, I've got -3, -2, and then 1 appears twice in the domain. I only have to write that once. Okay? And then for my range is -4. I'm going to write them in order, -2, 3, and 5. Don't worry about it too much if you don't write it in order, but it is a habit. that you need to get used to doing properly. Okay? All right, so now I have this relation right here, and these are the points that I have. So for my domain, it appears that my only domain is 1. And let's fix that bracket. We can do better than that. And then for my range, I've got 1, 2, 3, and 4. Okay, continuous relations. Okay, for continuous relations, instead of listing the coordinates, give the endpoints of the relation. Always give the smaller endpoint than the larger. Use a square bracket if the endpoint is included in the relation, and a round bracket if the endpoint is not included. So it is indicated on the graph by an open dot. So let's take a look at this example right here. Hold on. So notice that this relation, okay, has an open dot and a closed dot. Now, take a look at how they wrote the domain. So the domain they wrote with a round bracket for the open dot, starting at -4, and a closed or like a square bracket for +3. So right here, it passes through -4, -3, okay? So that's how they get those values. And then for the range, it starts at -3. We always go from least to greatest, -3, and +4. So way up here. Okay, we're not including the dot here because I still have all this. Well, I'm not using the open circle there on the y because I still have all of this graph up here that I need to account for. Okay, all right. For relations with no endpoint, use -infinity or +infinity when using infinity as an endpoint. Always use round brackets since infinity is not a number and is never considered included. Okay. So, if I look at my values for x, all of my possible values for x, now it looks like the graph begins at -6, but if you look right here, we've got arrows. That means that my graph is going to keep going, something like that, okay? So it is eventually going to include -infinity. So remember, here is -infinity, and here is +infinity, okay? So it's going to just keep going without end. So -infinity, +infinity, round brackets. The range, okay, it looks like the lowest point on the graph is also down here, but I know that the graph is going to keep going. So it is -infinity here, +infinity there, okay? Now, take a look. We're going from -infinity up to this point right there, which is at 2. Okay, so it's all possible values for y. So look at your smallest possible value for y and your largest possible value for y. Okay, all right. Next, list the domain and range of the continuous relations below. Use interval notation. All right. So for this one right here, I'm going to take a look at my lowest value for x and my highest value for x right here. So it falls between -3 and +3, okay? So I'm going to have square brackets, -3, comma, +3. Okay, now my range, my lowest value for y is at -4, my highest value is at 3. So I'm going to have here square brackets, -4 and +3. Okay, now let's take a look at the next one. So I have, for my values for x, my points are closed right here, so I'm going to use square brackets. My smallest value for x is at -4, and my largest possible value for x is at +1. So, -4, comma, +1. Okay, now let's take a look at our possible values for y. So, my graph, my lowest value is at -4, but if I trace it, it's going to keep going up till we get to this point right here, which is at +2. So, square brackets, -4, +2. Okay, looking at the linear one. So, looking at all of our possible values for x. Now, notice that I have an arrow. That means it's going to keep going into the negative infinity direction. Okay, my highest value is at +2. So I'm going to use a round bracket, -infinity up to +2. Close my bracket because that circle is closed. Let me erase it so you can see again. Okay, so if you notice, the point is closed. Now, let's look at all of our possible values for y. So, my lowest value for y is at -2. And I have the closed dot, so it's going to be a square bracket, -2. Now, remember we have the arrow. It's going up, okay, in this direction. So it's going towards +infinity on the y. So +infinity and close with a round bracket. Okay. Next, we've got a straight line with arrows on the ends. Okay, so looking at our domain, all of our possible values for x, okay, so it's going from -infinity to +infinity. Okay, so all of our possible values are going to be -infinity and +infinity. And then on the y side, it's going from -infinity up to +infinity. So -infinity, +infinity. Okay. All right, example 3, list the domain and range of the continuous relations below. Use interval notation. Okay, so I've got all of my possible values for x beginning at -5. It's got a closed circle. So it's going to be a square bracket, -5. All the way up to +6, but notice that my circle is left open. That means we don't include the 6 in the domain, okay? So what we're doing is just going to do 6 and a round bracket. Now, for the range, where's the lowest part of my graph? Well, the lowest part of my graph is actually down here, okay? And the highest part is up there. So for this one, I'm including the point, okay? So that is going to be at -6 up to positive 2. All right, let's take a look at the next one. Okay, so I've got, oh, this is an interesting one. Okay, let's look at our lowest value for x. The lowest value for x, I'll do it in blue. Comes at 1, but we're not including the point because it's an open circle, okay? So that means that we've got round a bracket at 1, comma. Now, my graph is going to keep going in the positive infinity direction. Okay, so right there. Actually, let me write that a little better so we don't get confused with the next graph. So positive infinity going in that direction. So that means that it's going up to positive infinity, and we are not including the point. Okay? All right.